Hello, welcome to Mahon Academy. We are here to take a look at an AP Physics 1 question today, and it's a question that gets repeated quite often. This type of a question in general. It's a it's a question related to Unit 2, and to be more specific, it's about Newton's second law. It's a relatively easy question, but let's just read through the question, analyze it, and see what the solution is and how we can solve a question like this. It says a 16 Newton box is at rest on a horizontal surface. The coefficient of static friction between the box and the surface is 0.45, and the coefficient of kinetic friction is 0.25. A horizontal force of 24 Newton is applied on the box. What's the magnitude of the acceleration of the box? All right, so right off the bat, acceleration is what the question is asking us for. Okay, so in this question, we are after the acceleration. How much is the acceleration? Okay, all right, the box itself is 16 newtons. That's the weight of the box given to us directly. And we know there's an applied force of 24 newtons. Okay, so if I were to draw the free body diagram, okay, I'm gonna show the whole box. I'm gonna represent the whole box with its center of the mass. So it's basically a point particle that is representing the box. We should position it at the center of the mass, okay? I'm just drawing it at the right side of the box to make it cleaner. But this point particle should be positioned at the center of the mass. All right, so we have the gravitational force or weight of 60 newtons. All right, so Fg is equal to 60 newtons. And then because it is supported by the surface, because it's resting on that surface, there is a normal force applied equal in magnitude. Normal force is also equal to 60 Newton. All right, and then we know there is an applied force equal to 24 newtons, and then there is friction force. We don't know what kind of a friction force, friction force is applied on this box yet. Is it a static friction force or is it kinetic friction force? That's something that we need to investigate. Okay, there's going to be an equation sheet in your AP Physics exam. But this equation that I'm about to write down is going to be in the equation sheet, but it's also a good practice for you to have it memorized. So a static friction force is equal to mu s, the coefficient of the static friction force, times the normal force. All right, and the kinetic friction force is very similar to it, but it is the coefficient of the kinetic friction force times the normal force. All right, so the values that we need to calculate the static friction force and the kinetic friction force, we already have them. Normal force is equal to 60 Newton. We have it from here. And then mu s and mu k are the coefficients of the friction forces given to us, 0.45 and 0.25. All right, so a static friction force is going to be equal to 0.45 times 60, and the kinetic friction force is going to be equal to 0.25 times 60. All right. This static friction force is what I'm mostly interested in at this part of the solution. So let's calculate how much that is. Okay, so 60 times 0.45. All right, I'm just going to quickly enter that into my calculator. I'm going to open up a calculator here. All right, let's see. All right, so I have my calculator open, 0.45 times 60. All right, that's going to be equal to 27 newtons, which is interesting. All right, so static friction force is 27 newtons. Okay, now we need to compare that with the applied force, okay? Because the static friction force is the force here that's trying to prevent this object from moving, okay? For the person, whoever is trying to move this box, for that person to be able to move the box, they need to apply a force in minimum equal to this static friction force. Okay, let's compare. So basically, you need to compare the applied force with the static friction force. Okay, in this case, the applied force is 24 newtons and the static friction force is 27 newtons. So that basically means that the static friction force is larger than the applied force. Basically, we are not providing enough force to be able to move this box. As a result, the box is not going to move. All right. The static friction force in this case is not going to be 27 newtons. It is going to match the applied force because the applied force is less than the static friction force. So although the maximum value for a static friction force is 27 newtons, in this question, it's only going to match the applied force. It's going to apply 24 newtons. All right, so if you write down Newton's second law, which says that the net force applied on any item, any object, is equal to the mass of the object times the acceleration of the object. The net force, the net horizontal force applied on this box, in this case, is going to be the applied force minus the static friction force, which is going to be 24 newtons minus 24 newtons, which is going to be 0. So 0 is equal to mass times acceleration. And from here, we can conclude that the acceleration of the box is equal to 0 meters per second squared. And thereby, the correct answer to this question is option A, 0 meters per second squared. And that's just simply because we are not applying large enough of a force to move the object. As a result, the object is going to remain stationary and it's going to have no acceleration. Thanks for watching this video. I hope it was helpful. Please write down in the comment section if you have any questions, concerns, if there is any specific topic in AP Physics 1, AP Physics 2, AP Physics C that you want me to review, or if there's any specific question that you want me to look at and solve. Thank you very much and have yourself a great day.